This week on Quality Digest Live, we'll discover how new trends in technology are shaping quality across the enterprise.
Plus, do fast food workers have a legitimate beef with their employers over wages? We'll find out when we come back.
Welcome back to Quality Digest Live for September 20th, 2013. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
Legitimate beef. I'm still cracking up over that. And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. Most of you are probably familiar with Moore's Law, that the number of transistors on integrated circuits doubles about every 2 years or so. Another interpretation that some take is that the cost of computing is cut in half about every 2 years. They kind of run synonymous with each other. And so the question is, today, how does that affect healthcare? Well, oddly, it doesn't. It should, but it doesn't. And that's the take by Antonia Regalado, author of the story, We Need a Moore's Law for Medicine. Even though much modern healthcare is technology intensive, you just have to walk into an operating room to see that, the cost of healthcare doubles every 13 years in the United States.
Kind of a reverse Moore's Law.
Kind of a reverse Moore's Law. And one reason for this, according to Jonathan Skinner, writing in MIT Technology Review, is that hospitals invest huge amounts of money on technologies that supply either questionable benefits or unproven benefits, or benefits for only a small group of people. Let's say like proton beam therapy. Very expensive, and the equipment is horrendously expensive. But that equipment, hospital buys it, it's still got to be paid for. So there is an incentive to get people to use the expensive therapies in order to pay off the investment, according to Skinner. There is really no incentive toward using inexpensive therapies that might be equally as effective, or some might argue in some cases more effective, and again, according to Skinner. So what we need to be doing, according to Eric Topol, a cardiologist and researcher and director of the Scripps Translational Science Institute, San Diego, is to topple medicine's entire economic model using low-cost electronic gadgets. Regalado reports that Topol walks around the hospital using an electrocardiogram reader that attaches to a smartphone. The idea is to use Moore's Law to drive down the cost of healthcare. And in other words, the same low-cost technology that allows almost everyone to own a computer or a cell phone or a DVD player could be used in a healthcare setting if there was an incentive to do so. But there isn't, and that's the whole problem. And that's kind of what Topol and Regalado and these others are getting at, is that all the incentive right now, and including government grants and so forth, are all toward investing in new technologies and all this type of thing. And of course, once the technology comes in, it's got to be paid for, regardless of whether it's doing any good, any real good or not. So there needs to be incentive. There needs to be probably, I think they're saying, government incentive to be investigating ways to use existing low-cost technology in a medical setting, and, like they say, make use of Moore's Law.
I don't think anybody's saying that we shouldn't push the edge of research and development and get these new technologies online, but I think what you're saying, what the article is saying, is that the over-reliance on that, which is built into the costing structure of the whole system, is such that you can't kind of ever get away from it. You just have to charge more and charge more and charge more, and for questionable benefits.
Right.
That's really the question, is does that make sense?
And there needs to be incentives to do stuff like what Topol is doing, is using simple, like a smartphone and simply a sensor. Electrocardiogram is just a sensor or blood pressure monitor or whatever that goes to a smartphone. Those are already dirt cheap, and there you go. This is a way to leverage consumer technology essentially into mainstream medicine. So
good stuff. Good stuff. Well, good. Thanks, Dirk. Good story there. Okay. Also in the news this week, Eiji Toyoda passed away at the age of 100, a milestone that he reached literally just a few days before his death. He was actually born 1913, September 12th, and he died 2013. I think it was September 16th or 17th.
Yeah.
Earlier
it's interesting. These old quality gurus, they live for, how old was Duran?
Duran was 105, 103, I believe. Gosh. Well, boy, I tell you, but that's the thing about that. I mean, talk about knowing your spec. I mean, he made it to 100 plus like 3 days. So, boy, these guys really are on it. I'll tell you, Eiji Toyoda was a close member of the first family of the Toyota Motor Corporation. Corporation. He was the nephew of founder Sakichi Toyoda of the initial loom company that Sakichi founded back in the early 20th century. As president and later chairman of the company from 1967 to 1994, Eiji spearheaded Toyota's international expansion. And along with Taiichi Ohno, he was also one of the key architects and proponents of methodologies such as Kaizen, just-in-time manufacturing, and Kanban systems. Today, of course, these lean principles are acknowledged to be the hallmarks of the Toyota production system. And hey, you can thank Eiji Toyoda along with Taiichi Ohno and many of the others in Toyota for bringing that forward. So celebrate Eiji Toyoda's life. Read the story just below the player page right down there. And in fact, all the articles and stories that Dirk and I are going to be covering on the show can be found right below the player page right down there.
That's right. Okay. Well, if you follow technology, you are familiar with terms like mobile apps, cloud computing, big data. We all hear those terms almost every day. But do you understand or even realize how these technologies are affecting enterprise quality management system software, something that many of you probably use within your own company? And if you don't know how that affects you, well, that's good, because that's why our next guest is here. Joining us today via Skype is Judy Fainor, Chief Architect of Sparta Systems. Good morning, Judy.
Good morning, Mike, Derek. Glad to be here today and talking to you about this topic.
Great. So how are these technologies affecting enterprise QMS today? I mean, let's start with just, I don't know, let's start with the cloud. What's going on with that?
Well, a lot of interesting things going on with the cloud. So as you know, the cloud provides the ability to have services and applications reach via the internet. But related to quality specifically in the enterprise quality management space, there is the need today, because of the globalization of companies, and not only vendors and manufacturers, but to reach their external suppliers, there is the need to now get involved with the cloud to extend your quality workflows outside the boundaries of your four walls. So today, if you look at the best practices for, let's say, vendor to supplier quality management, a lot of that interaction is a manual one. They do the exchange of important data by email, fax, spreadsheet, and this is very error-prone, let alone inefficient. So being able to leverage cloud services that actually extend your on-premise capabilities out to those external parties without direct access to your on-premise systems is key. So this gives you that ability to have a consistent workflow, a consistent process, and an integrated process all in the same boat.
And I would imagine this ties in then to mobile apps as well then, right? I mean, using your mobile apps to access, or using types of mobile apps to access the cloud, is that right?
Absolutely. So as you know, our landscape of our workforce is changing. No longer is it 9 to 5 a normal workday. As companies globalize and they extend all over the globe, there's the need to access those critical applications 24/7. You know, devices are becoming so prevalent. This year in 2013, mobile devices actually surpass PCs as the most common form of web access tools.
And Judy, are these both for mobile apps for monitoring, or is it also mobile apps for maybe inputting data into a QMS?
Both. So into the QMS system, the mobile application, I think the biggest use case we have right now is, as I talked about, extending that workflow out. As you know, in a quality workflow process, there's the need for tight monitoring of the flow of that quality data and the workflow process, but there's also the need to get involved in that process and from time to time, let's say, do an approval, add a document. These types of operations are now becoming critical to the efficiency and outcome of your quality and your risk management within your organization. So the ability to be able to do these through mobile access to on-premise systems is becoming critical.
Okay, now the one thing I want to spend now a little bit of time talking about is big data. And you know, there is if people want more information on this topic, there is a webinar coming up
on September 24th.
September 24th.
Yep, next week. Okay,
and one of the interesting things you're going to talk about in that webinar is how all this data that's being collected from various, sites within a company, whether it's via mobile or however it's being collected, how this data can be analyzed, including, I think you said, even data related to your social media. And can you tell us a little bit how all that is tying together, particularly the social media part?
Yeah. So, the big data has been around for several years now. It's only recently that it's actually showing up on, Gartner and Forrester lists as CIO concerns, because what was once the means for storing vast amounts of data and quick query is now being surpassed by the ability to perform analytics. So being able to take this data from disparate systems of many formats, whether that's structured, semi-structured data, and bring it into a central repository, then apply analytics on top of that is giving organizations insights into that data, which was once a liability. I mean, you have these systems, they're producing this data, and you need to keep it, whether you're archiving it or whatever. But now being able to actually leverage that and get the value out of that data. So where does that play in with quality and, as you said, social media? Being able to take data from your enterprise quality management system and also inject that into this central repository for further analysis. Maybe being able to gain insights or get root cause analysis based on change requests or non-conformance that has been reported. In consumer products, if you can now also combine that with social media, let's say blog content, Twitter information, Facebook, you can now do some textual and sentiment analysis on that as well. And when you're talking about brand protection and risk management, they all play a factor. So again, what was once a platform for dealing with huge amounts of data is now it's being turned on its head, and the value of analytics and predictive and sentiment analysis is coming to the forefront.
So Judy, what you're saying there is that basically, if you're monitoring your Facebook page, let's say, and you know that you become aware of an issue that consumers of yours may be talking about, that this gives you the ability to kind of understand what's going on quickly, bring that into the system, crunch that data, maybe understand what the consumer experience is, or is there another level of this?
No, absolutely. It's kind of letting you have the insight into what's coming, what's being said, and allowing companies to be proactive. All too often now, we're kind of in that reactive state. This is giving you that ability to jump out and look at potential problems or potential customer issues coming down the way.
Okay. Well, Judy, thanks for joining us today. We're going to be talking about these topics a lot more in depth.
That is September 24th, and it's our normal time, which is 11 a.m. Pacific, 2 p.m. Eastern. You can register for the webinar, I believe, right in Judy's article, which is on the player page right below us, right here.
That's right, and you'll probably be getting an email talking about it as well. So if you want to learn more about how the cloud and mobile computing and big data and software as a service and so forth, how that is going to affect your quality management system software, you'll want to come attend this webinar. Judy, thanks for joining us today.
Thank you.
Okay, so long.
Thanks, Judy. We'll see you on Tuesday. Good stuff there. Thanks, Dirk.
Yep,
and
sure.
we look forward to your hosting that one. So
there we go.
It's going to be great. So if you want to find out more about that, again, register for the webinar now. Okay. Well, we're going to turn now to another feature article that we covered this week, and we actually talked about it a little bit last week too, from live from the floor in the Quality Expo in Chicago. This was an article from Bill Levinson called "Fast Food, Henry Ford." Who else? Henry Ford versus the SEIU, and the SEIU is the Service Employees International Union,
yep.
And the SEIU is requesting $15 an hour wages for fast food workers. Their members who are fast food workers. And this was a piece, again, by Bill Levinson. It appeared in Monday's issue of QDD. So the question on the floor is, does this make sense? Does it make sense for the SEIU to be demanding $15 an hour for their workers? Does what they do create value? Is it worth it, right? And that's the question that Levinson asked. And not according to Bill. When Bill looks at it, he says, no, it's not worth it. And he doesn't just say that from his own perspective. He brings in, of course, his normal focus point.
And let me interject something right here. I think there was a little bit of understanding with what Bill's. I don't think knowing Bill, I don't think Bill was saying, oh, no, we can't, it's wrong to raise the minimum wage. I think what he was saying is it's wrong to just randomly assign a number to it. There's got to be some sort of tie-in.
Well, what he's saying is, and he's said this many times, is that there's got to be a practical business reason for doing that. And touching on Ford always had a practical reason for being able to raise wages. Ford was notable for paying his auto workers way more than the norm 100 and more years ago. But he didn't just do it. He didn't just hand them that money. There was a good practical business reason for that because his operations were so darn efficient.
Right.
And he made those operations efficient, and then he returned some of that money to the employees.
Which is also a key part of this.
That's right.
If you're going to be efficient, you should be,
You should be compensated more. He also was able to pass some of those savings on to his customers in forms of some lower pricing. But what happened was by having more engaged workers who then would make more money and want to continue to make more money, what do? They were more innovative. They were more creative. They looked for ways to reduce waste in their own operations because they had a dog in the fight. Right. And it was very well known, hey, the better we do, the better you're going to do. The rising tide will raise all boats. So logic dictates that a job cannot pay more than the value to which that job would assign, would produce. And the fast food industry as it's currently constructed, I think, doesn't have much of any excess value within it as it's currently being done.
Right. And
you can't pay the people more if there's not more value. And that's, I think, is a problem. Now, a lot of good reader quotes on this. Let's read the quotes on this. But there's one quote, one short one, succinct quote that I want to bring up now that I want to address because it raises a good point on this.
And actually, just as a counterpoint to what I know the quote you're going to use,
yeah, right.
Levinson's argument was that in order to create value, they need to get rid of waste.
I'm going to get to that. Yes,
okay,
yes,
okay.
I'm going to get to that.
But it's kind of in contrast to what this next comment is.
Well, it kind of goes along with it.
Goes along with it.
I'll show you. I'm going to tie into it. But the reader comment was, and drum roll please, it just means that fast food is too cheap if it cannot sustain people on livable wages. Davey D.
Yeah. Do we need a 99-cent burger or a 79-cent burger?
That's exactly the thing.
Right.
Maybe prices have to be higher.
Yeah.
For fast food. Maybe it is artificially cheap. And as a
we know it's artificially cheap.
Yeah, and maybe as a nice little consequence of that, we'd eat less fast food, we'd all be healthier, right? I mean,
right.
But the inputs to there are such that people expect food to be really, really cheap, and because it's an inefficient system, and I'm going to talk about that here in a minute, because the system is inefficient, they can't raise prices, right? And they can't raise wages because the system itself doesn't bear it. Going back to Ford systems became more efficient, and he could raise the prices. He could raise the wages he paid people. So maybe prices have to be higher, and maybe efficiency has to be increased. And maybe some ways you could do that are an automated assembly line for burger production, right? I mean, why not? Slice the tomatoes, slap it on a burger, why not? Reduce walking. Walking is a huge source of muda in fast food environments. You watch people walking around, you're like, that's crazy, right? Duplicated efforts. You give your order to a register or a cashier, and she or he gives it to somebody back there making the order. Why not just punch it in a touch?
Like Blazing Onion.
That's right, Blazing Onion. Great example that Jeff Jewer and Christine Pammer talked about a few months ago. There's the argument that you hear sometimes from Luddites and people that are wanting to protect what's here is that, well, what's going to happen to all those jobs? Well, yeah, they may go away. I mean, but the example that Bill uses in this piece is you look at like ditch digging, shoveling, right? I mean, back in the day, people would shovel. If you needed a big house foundation, you had a bunch of people shovel it, right? Yeah. But now you use a backhoe, right?
One guy.
One guy you work your backhoe, and that one guy makes a lot more.
Yeah.
And you could say, well, maybe those jobs are gone, and maybe we mourn those jobs. I don't know who the heck would mourn a job where you're making below minimum wage and breaking your back, right? Yeah. But I mean, and maybe one day we're going to mourn the loss of these fast food jobs. But I don't think so. I think that what happens is those people get integrated into the environment, the advances happen, and then you're able to make that work. So, interesting story. I think that you want to read this one again. Fast Food, Henry Ford versus the SEIU by Bill Levinson. Check it out right below the player page.
That's right.
Down there. Okay, we're running real late, so I want to move on now to our tech corner. A good one for you. We love doing this when we have a guest come into the studio and join us and show off their latest product. Our guest here today is Eric Kloss of 8tree, and Dirk and Eric are going to show you a few new products from 8tree. So take it away, guys.
Thanks, Mike. Yep, well, as Mike said, we've got Eric Kloss from 8tree. He is the Chief Technology Officer and the co-founder for 8tree. Eric, thanks for joining us.
Hi, Dirk.
And what are we looking at today?
First of all, thanks for having us in Tech Corner today. We're really glad to present it.
No problem.
So Eiji is a German-American startup company that makes surface inspection systems that are special in several ways. And I'd like to show you today the fastCHECK system first. Okay. It's special in a way that it's incredibly fast, easy to use, and it's application specific. And the first application that we picked was actually triggered by the aircraft industry. Okay. And it's about checking fasteners. Probably everybody of you have seen fasteners when you enter an airplane.
Actually, let me try something, if we can do that. So we can, if we got the gauge cam here. Okay. Yeah. So, okay. So if we see over here, so these are the fasteners that you would find when you walk up to an airplane. You're boarding an airplane. You see there's like a jillion of these fasteners holding the skin on the plane, essentially.
Exactly, right? Thousands of them on the fuselage, on the wing, and they have to be installed flush, really. So they should not be sticking out, and they should not be too deep. Okay. For two reasons. So if they are out, it's an aerodynamic problem. So fuel consumption goes really up, and that's a big problem today. And the other problem is if they are too deep, it's not stable. It's a structural problem then. Okay. So they have to check all these fasteners, and it's a problem because right now they're only using manual gauges, and it takes forever to check them. So what they do, they manually check by using their hands.
So they kind of run their hand over the skin and get a feel. Okay.
Exactly. Actually, you're very sensitive for that. So it works fine, but it's of course not very objective. Right. So only when they find a problem, then they use that dial gauge and check the fastener depth or height.
And what kind of precision are we talking about with these mountings?
Accuracy is actually very tight. The tolerances are tight. So it's about 2 thou for sticking out, and it's about 7 thou for deep fasteners.
So what, 50 microns?
50 micron height, 0.2 of a millimeter, roundabout. Okay. So that is the requirement if you want to check those. And we came up with an idea to use an optical scanner.
Now this is a structured light scanner, white light scanner?
Exactly, that's a structured light scanner. There's nothing really special about that except that it's very fast. Okay. And let me really quick do that measurement. And
so it did a quick scan of the skin, and what are we looking at here now on the skin itself?
So the system finds automatically the fasteners, and then it measures the depths of them. So,
so what it did is it scanned the skin, and then it projected then back over the top of the actual fasteners how much intolerance they were in, or if they were in or out of tolerance, right?
Actually, that's the novelty of that system, that it uses like the surface of that part as a screen to project the results on. And the idea is really to have a color code, so the operator would only look at the color and he would see, okay, green color means this is intolerance, and red, blue color means it's either too deep or too high.
So he doesn't have to go back to a computer or anything. Basically, he takes a scan, he or she takes a scan, and immediately, if they don't see all green dots, they know there's something wrong.
Exactly.
Okay.
So what they usually do then, they circle those bad fasteners, and they are being drilled out, and the next size, bigger fasteners being installed.
Okay. Now, I think you told me that this only kind of scans a 8.5 by 11 kind of a sheet of paper size scan. So if they were going to scan a whole fuselage, they would have to kind of hopscotch the scanner down the plane?
That's exactly what they do. Or they installing this system on a robot or on a handling system, and they even think about installing it on the fastener installing system to check the fastener right when it's being installed.
Okay. And I think you have a video that kind of shows this, is that right?
Yeah, a very brief video we have to show how that is being applied on a plane. This is actually an animation that we made because people don't really understand the principle of projecting the results on the part. So we see the scanner, it has a camera and a projector on the other side, and now you see the surface of an aircraft, and you see these thousands of fasteners. And you can imagine it's hard work really to inspect them all by hand. So you see the scanning process, and pretty much in a second after that, it projects the results. In this case, they are all good, so all green dots. It's battery powered, that device, and it's operated by a remote control. And so this is how the system would move along the surface. So it still takes some time, but it's about 10 times faster than the other approach with using a hand gauge. And there you see red dot means it's coming out, blue is a deep fastener, and we can also check the angle, whether it's installed crooked. Okay.
Okay. So this application happened to be a fastener application. I understand you've got a couple other applications.
Yeah, so that was all triggered by the aircraft industry because they had that problem. And when we developed that principle, we found we have other applications that we could use. One is being checking for dents. Of course, there are dents in many parts, for example, also in airplane parts and in automotive parts, hail damage, for example. And it works very similarly. So the surface is being entirely scanned, and then you define a certain area that you want to inspect.
So you're just drawing a box around the area that you're interested in.
Exactly.
And it just scans and gives you, looks like a color contour map just of that area then.
Exactly, that's what it is. So it compares it to a reference plane, and now we see each little dent. So there's a big one that you can easily see with your naked eye.
So you're moving the cursor, as you move the cursor over that dent, it's giving you an indication of how far out it is, either up or down.
Yeah, exactly. So red, or the reddish colors mean it's coming out. The bluish colors are deep fasteners, deep dents.
Right.
So that's actually the second application. We call it dentCHECK. And for the purpose of demonstrating it, we put it all in the same system. Actually, these are separate systems that can have different fields of view and so on.
Okay. So basically, so what you're saying is the hardware is the same. It's kind of a software application that varies,
yeah, pretty much a software.
Other than maybe the optics, the field of view you mentioned. Okay,
yeah, exactly.
Okay.
So, and again, based on the same principles, we can also check what we call gap and flush measurement.
Okay.
So on that sample, we see a gap that is increasing in size down to the bottom. And what you can't see so clearly, it's also a gap problem. So they are not exactly a flush problem. They are not exactly flush.
Right. Just what Eric's talking about is if you could look end on this, you would see that these two pieces of poster board aren't planar with each other. They're kind of skewed from each other. So not only is there a gap difference, but there's also a flush difference as it moves along from top to bottom. So it did a scan, and now we're getting our gap and flush feedback.
Yeah, and the idea or presentation of results is very similar. So we're using color codes to make it really easy to understand. So if you're looking at green colors, everything is fine. So the gap is okay in this area, and the flush measurement is also okay. But if we're going down here, we see that the flush numbers are increasing, so the circles are getting bigger and bigger.
And if you can leave the gauge shot back up there, Daniel. So these arrows, those are telling me whether my gap is in spec, right? So the arrows are gap, and then the circles are flush. So as as I'm going down, I'm seeing these circles getting bigger and bigger and bigger, which means my flush is getting worse and worse and worse. Is that
and that's exactly the idea of presenting these results here. To have, actually the operator doesn't have to look at the numbers really, but he just checks for the green color and then he's good to go.
Okay. Now, what you've been talking about mostly aerospace. Is that typically the application for all three of these technologies, or are there other?
Yeah. So we are a small startup. So we started concentrating on the aerospace industry, but we're getting demand from the automotive and other industries to apply the exact same principles for their measurements. For example, dent measurements on cars, you can do the same thing. And we are talking also to insurance companies right now that are interested, for example, to if you have hail damage on cars, to check for those.
And so the kind of to wrap all this up, basically what you've got is the technology is a structured white light scanner that scans a surface and then immediately projects back onto the surface how that surface varies from whatever tolerances you're looking for. And I'm assuming those tolerances are pre-programmed into the box. Is that right?
Yeah, that's right. So there is a PC inside that system, and everything is pre-programmed. We can very easily change also these settings by using a barcode and tell the system, okay, now the tolerances are different.
Oh, really? So you could use your cameras to scan a barcode. The barcode's going to tell it what measurement program to bring up. Okay.
to make it really easy for the operator now to switch from one tolerance set to the next one.
And this box is all there is to it.
Right.
Other than for programming purposes, basically once this is programmed with the test routines, you're just going to take this box, put it on this looks like a regular camera tripod.
Yeah, so it can be put on anything. Just for that purpose, we put it on a tripod. But you could even use the system handheld, and yeah, it's battery powered. It's completely self-contained. So.
Okay. Well, again, this was the fastCHECK, the gapCHECK, and the dentCHECK.
Exactly.
Right?
Yeah.
And again, this was Eric Kloss from Eiji, Chief Technology Officer and co-founder. Eric, thanks for joining us this morning. Appreciate it.
Thanks for having us on the show, Dirk. I appreciate it.
No problem. Back to you, Mike.
There you go. You have it from Eric Kloss and Dirk, the Eiji Tech Corner. 3 really good products there you saw on this week's Tech Corner. It's always nice again to have a guest come in and join us on the studio and go through Tech Corner with us, Dirk. That was fun, huh?
Yeah.
Yeah, good product there, I think.
It's cool. You know, we're seeing more and more interesting technologies come along that are really more operator friendly, and this is kind of one of those technologies that falls in that. As Eric pointed out, structured white light scanning, that technology's been out for a long time. So the measurement aspect, as Eric said, is nothing new, but the idea of taking that now and projecting the information that the user needs to act on, projecting that right back on the work surface, so you don't have to go back to a computer and look at something. That's actually brilliant. That's great stuff.
It's getting better and better every day. It's always exciting in this industry of ours. All right. Well, thank you again. Thank you, Eric, for joining us. Thank you, Eiji, for sending along the products. Thank you, Judy Fainor of Sparta, for joining us via Skype and chatting about next week's webinar coming up on September 24th. Make sure you sign up for that. And that's this week's show. So thank you all for joining us. Come back next Monday for a full week of QDD, and we'll see you right back here next Friday for QDL.
That's right. So long.
Have a good weekend. Bye.